from memory that after the International Space University came to Cork and were hosted at CIT, now MTU, in 2017, there was a white paper produced on how the space industry could be developed in Ireland. That was presented to the government. I know as well that the Department of Enterprise has a national space strategy 2019 to 2025. That's part of the Project Ireland 2040 program. And looking at that this morning, it's very much based on the hard engineering. I see mention of satellite communications, navigation, data management, propulsion, payload. But I think the space industry in Ireland is wider than that, because you have the research going on in our third level education facilities. You've got lots of science research in the astronomy, cosmology area. And the other big part of science in Ireland, or space in Ireland, is outreach, education, and communication. So I think we're going to cover all that today. So first of all, thanks to Engineers Ireland for hosting this and inviting me to moderate, and thanks to all of you for attending. We're at 38 people so far. And thanks to the speakers. So we have 3 great speakers. Before I introduce them, they're all going to speak for around 15 minutes. We're going to have a Q&A at the end. So put your questions in the Q&A part of Zoom, and we'll gather those up at the end. We should have 10 minutes, hopefully. The session is recorded. It'll be available to everybody at the end. It'll be on the YouTube channel, the Engineers on the YouTube channel, and so on. So again, thanks a million. If our speakers here, first up will be Niamh Shaw. So Niamh's our science communicator extraordinaire. You've seen her on television, RTE, BBC. You've seen her deliver TED Talks and writing for the Irish Times and Sky at Night and what else? One woman shows, etc. So Niamh is going to talk to us about the space industry at the moment and the status of the space industry. Then Mark Daly from the Technological University of Shannon is going to talk to us about the LOFAR project, which is the low frequency radio array. I believe it's in Birr. The Irish section is in Birr. It's part of a European-wide radio telescope project. So I'm interested in hearing about that. And then Alan Giltinan is going to talk about the space strategy, the recent survey from KPMG on how we're going to fill the gaps in that space strategy. And Alan is the manager over at the Blackrock Castle Observatory, again, part of MTU. Fantastic facility here in Cork for people who want to look at science outreach and science research. So with that, I think I've covered everything I need to cover to get us going. So I'll hand over to Niamh. And again, put your questions as you get them, put them in the Q&A session. We'll hopefully get back to them at the end. Thank you.
Thanks, John. Thanks. Good afternoon, everybody. It's great to see such interest in this sector. I mean, you know, I'm obsessed about all things space. As John said, I'm a communicator, and I'm very passionate about highlighting the level of activity happening in Ireland around the space sector. And I've been talking to many people, and it's great to be writing for the Irish Times. You get a chance to really have a good chat with people. So I don't really have a presentation as such. I'm just going to share some links, because I think I want to give you some information if you're interested in knowing a little bit more about how you can get involved. And I'll just give you some background to some of the things. So I'm going to start with I've got like 2 slides. So I'm going to start with that, and then it's all just web links. So let me just share my screen with you for a sec. And we're going to start here. And if you're a space nut like me, unless you were under stone yesterday, we had quite a seismic moment in the story of humanity and space, in my opinion, in that India, who has been trying for the last 15 years to have a presence on the moon, finally achieved with its 3rd mission, the Chandrayaan-3, and safely landed on the moon. Its lander is called Vikram, and a rover called Pragyan, meaning it's Sanskrit for wisdom. And they also had another first, in that they were the first team to successfully land in the southern region of the moon, which of course is an area that we're all particularly interested in from a science perspective, and also I think from an economic perspective, because there is water on the moon, which gives us the opportunity to really think seriously about having a presence on the moon long term, which is a whole other conversation, which we can talk about in the Q&A. But this is important because It also is, I mean, India did this with a much smaller budget than a lot of the other big space agencies. So space is becoming affordable, very affordable, and that's changing the whole climate. And the reason for that is a lot of space agencies are changing their business model, where they before would have done everything internally from start to finish. Like that would have been NASA's model way back in the day, and Russia's Roscosmos model from in the day. More recently, NASA changed its business model kind of around about the 50th anniversary of Apollo, to start subcontracting work. So they hire companies like SpaceX to launch their astronauts and European astronauts to the International Space Station, one of which is happening tomorrow, and then subcontracting different parts to build and construct rockets, spacecraft, satellites, all sorts of stuff. And that model is kind of rolling out now right across the world. And the European Space Agency is exactly the same. So we, as a member state of the European Space Agency, can avail of all manner of contracts that they advertise. And not only that, there is a European Union organization that companies or they don't necessarily have to be purely based in space, but they're engineering or technical in some way, and they want to get a slice of that business. There's nothing stopping you from doing it. This is my second of 2 slides from Tech Summit, which happened in June. And it's great that there was a presence and a conversation about space at Tech Summit, and it's perfect matched with this webinar today, because it's the same conversation that we're having, is that the level of technology that we are now combining with the space sector is really developing. So we have 3 kind of key players there, and 3 very successful business stories in the Irish space industry. So just beside me is Fintan Buckley, and he's a co-founder and CEO of a company called Ubotica, who are using artificial intelligence in combination with satellite systems, and they had a proof of concept awarded to them by ESA, and are now going ahead with it. So what they're doing is they're using AI to distinguish between images that are worth sending back down to Earth and images aren't. So for instance, if they're taking an image of Ireland and it's a cloudy day, there's no point sending those images down. So up, before those images are transmitted down, listing bandwidth, the AI is determining them around that way. And then in the middle, we have I call him grandfather of space, Daly Gleeson. Danny has been involved in the space sector probably longer than anybody I know, and he's really championed the Irish space sector. And he is the CCO of a company called Railtra Ireland. He also is formerly Curtis Wright up in Belfast. And Railtra are just this incredible success story. A small company who broke ESA's rule in that they usually don't use startups for their major launches, but they made an exception with Railtra. And during lockdown, Railtra had a vision system on board for the launch of the infamous James Webb Telescope, which is a telescope that has revolutionized the way we look at our skies, giving us a level of clarity that we had to some degree from the Hubble telescope, but it's like we've got a whole new pair. Somebody's been to Specsavers and we've a whole new set of lens. So a key part of that was to ensure that after James Webb was launched on the top of a rocket, that when the fairing, which is the external part of the rocket, was deployed, you have the actual spacecraft, the telescope itself, and to ensure that it wasn't damaged during launch, because this is a very delicate instrument, there was a camera inside in the fairing, and that was provided by Railtra, and it was a first. It was the first time that had been done, and it did it very successfully. And so from that, now they've been providing more and more vision systems for not only for ESA but for NASA, and on and on and on. I visited them, and I've done a career video about that company for Zero Ireland, which is the education and resource arm of the European Space Agency. It'll be out soon. And then on the far side of the panel, then you have Ruth Mackey, and she is a trio of the Mackey family. Herself and her 2 brothers set up a company called Embryonics. And what they're doing is they're using satellite systems to set up basically a new kind of broadband service using satellite, very similar to kind of using optical fibers as a satellite system, very similar to what Starlink is doing, except the technology is very different. So they're high-tech companies, and they are really developing, and they've put a lot of time and effort into their research and development, and now are kind of paying they're getting the dividends of all their hard work. But they started with a lot of support, and so that's my slides for now. So let me just stop sharing that, and I'm going to share a few links that you might find useful. yeah, here we go here. So, so for an overview of everything that I'm going to be talking about, I would lead you to an article that I wrote in March where I did a kind of a review of the Irish space sector. And if Al is going to be talking about the Irish space strategy, I'm not going to go on about it too much, but basically the thread of the article is that, you know, we had the Irish space strategy. I spoke to Conor Sheehan from Enterprise Ireland, who's one of the delegation to the European Space Agency, for working with companies for opportunities with ESA. And already they've 95% of their 5 pillars accomplished. And so they can't cope with the level of opportunities that are available. And then the Department of Enterprise, Trade and Employment also gave a quote that they're continuing to fund, and they announced that they're adding an extra 127 million in funding towards the European Space Agency, which then has dividends in Ireland. And we have, I hope my internet unstable, and there's a 7 times return for every euro that the Irish government puts in to European Space Agency. There's 7 times return on investment on that. So there is massive interest in developing this sector. So if you just Google Niamh Shaw Irish Space Sector, that'll come up, and it gives you a very good overview of that. And there's some key players. Daly speaks there, and that Niall Smith, who Alan works with from MTU, and it was involved in working with the government and crafting the Irish space strategy. We have Conor Sheehan from Enterprise Ireland, and we have I mentioned some companies that are also successful. There's that. What's also happening, because there's this gap, so there's this funding available, and then there's companies that are involved in the tech sector, but they don't know how to get into the industry. What's happened, I'll leave an article from Silicon Republic, which summarizes a new the Irish Space Association, and that's been rolled out by a number of players. One is Enterprise Ireland, also on the board of just basically the foundation members, but they want more people to get involved in running the Space Association. You have Patricia Moore from a company called Mindseed, and you have John O'Donoghue from NBio, another great success story for Ireland. And they have a meeting coming up, I think, on the 7th of September in Cork, in Tyndall. And what they want to do is they want to help any companies that are interested in understanding how they can get involved in providing software or parts or components, or taking advantage of data that's freely available from our European suite of satellites like Galileo and all that. And they want to explain how you apply for funding and everything. So that's the Irish Space Association. So again, that Silicon Republic article is very good. And then I would lead you to Enterprise Ireland's website. So if you go Enterprise Ireland Irish Space Sector, you should get this page. So Enterprise Ireland work directly with the Department of Enterprise Trade and Transport, Enterprise Trade and Transport, I think it is, and with the European Space Agency, and they form a delegation. And so they work very closely with the European Space Agency. The European Space Agency say, oh, we've got this project coming up. There's so much available on contracts for Ireland. It's their job to let Ireland know about it and to try and connect Irish companies to apply for funding for that, whether it's in research or whether it's in industry or whether it's applications. All that is available to you. And so since the publication of the space strategy, the Enterprise Ireland have been summarizing the activities. And so they have these reports. This is a PDF here, and this was published just last December. And if you go into that, it'll summarize all the different companies and what they're doing. I'm not going to go through it because it'll take a long time. It also goes through what the pillars are of the National Space Strategy. As I said, they've completed 90% of that. And then when you go further down, here, if you go to the Space Industry Directory, you'll see all the companies that are active through this ESA delegation. But that's not to say they're not the only companies that are available. So these are a list of let me just go. I just want to go to so you have Enterprise Ireland, right? So now Enterprise Ireland also work with Solutions Centre, which is like a business incubation unit where there is groups of 50,000 euro available for companies to develop their ideas, and then there's additional funding called Spark Initiative 2, and that's run out of Tyndall. Peter Finnegan is the CEO of this organization, and again, this is to help startups if they have an idea, particularly startups that want to take advantage of data that's available to them from the suite of satellites that the European Space Agency run. So there's all this information from satellites that are looking down on Earth observation data, whether it's climate data or air quality data or whatever, even just like satellite data in terms of using it to determine distances and things, all that data is available. And so the Space Center works with those companies. It gives you all there are some videos there of some of their success stories. And then these are a list of some of their supported companies. And a lot of these companies aren't working in the space sector. They're just taking advantage of the data that's available to them, working out of that. And then lastly then, because I'm just conscious of time, we have then a whole other board. So that's all European Space Agency stuff and funding and available. Then you have a whole other board, which is EUSPA, which is the European Union Agency for Space Programs. So their job is on behalf of the European Union for countries that are member states of the European Union to take advantage again of opportunities for our country, Ireland, to make use of content, satellites, all that information that is completely free. And their job, again, is to help you with that and to link you in with Horizon, which is like EU, big, massive trans-European funded projects. And again, you can go onto that website there, so EUSPA. And then lastly, then, if you want to have a look at the National Space Strategy, if you just put in the National Space Strategy, you can download as PDF. It's like 50 pages long, and I would suggest just start with the executive summary. So that's all I'm going to do. I'm just going to share my contact details with you, because I say that is just like literally a whirlwind overview, but I just want to let you know that basically there's a lot going on and it's a great time to get involved. So if you have an idea where you can take advantage of data that's really available from satellites that are observing Earth, or others, or you have some sort of component or software that you believe would be of use for the space sector, then these are the people that you should be getting in touch with. Okay, over to you, John.
Thanks, Niamh. I was about to give you the 2-minute warning, but you're bang on schedule. So I'll hand over now to Mark, who's going to tell us about the low frequency radio array and the data they're getting from that. So over to you, Mark.
Okay, thank you very much, John, and thanks to NGOs Ireland for the opportunity to talk to everyone about what we're doing. So I'm going to share my screen with you now. So I have a bit of a presentation here, so I'll just go through it with you. So sorry, this thing at the top here, I'll move that away. Okay, so effectively what I want to talk to you about today is how we use computer vision, that's the CV part, to essentially detect and classify solar radio bursts that we detect using the low frequency array in Burr, and that's the SRB part. So my name is Mark Daly. I'm in the Faculty of Engineering and Informatics in TUS in Athlone. So what I'm going to cover very briefly is, first of all, what's an SRB? So what is this artifact that we're trying to discover? What is ILOFAR? What is the instrument we're using? How objects are detected? And then finally, synthetic data generation, which we find is necessary in many cases when we're dealing with rare events to try and actually train systems to detect them. So first of all, what's an SRB? Well, we're all familiar with the sun, and we all know that sometimes it does things that it probably shouldn't do, like give a bit of a hiccup. A coronal mass ejection is basically an eruption from the surface of the sun, and it spews out energy. So you get electromagnetic radiation from the radio right up to the gamma rays, but you also get charged particles coming out as well, and the solar wind. But it can be far more stormy-like when you actually get a coronal mass ejection. And if the Earth is actually in the path of a CME, a coronal mass ejection, then we want to know exactly what's happening, how hard it is, and also when's it going to hit us. So with the radio emission that comes out from these coronal mass ejections, they travel at the speed of light. The particles don't, because they have mass. So the radio emission and the electromagnetic radiation hits the Earth about 8 minutes after it erupts from the sun, if we're in that path. The charged particles can actually take a number of days to arrive. So we have possibly an early warning system for adverse space weather. Now, What is space weather? Space weather is essentially events that occur typically from the sun itself that are going to affect what happens to us on the planet Earth, because we are tiny compared to the sun, as you can gather. So this image gives you some ideas of things that can be affected. We can have radiation affecting the satellites. You can have charged particles affecting astronauts, get radiation. If the satellites are affected, GPS can be affected. So everything down on the planet can be affected. So navigation, if you're in a high-flying altitude plane, so you can be affected there because you have less of the atmosphere to protect you. Your radio frequency, your high-frequency radio waves can be affected by that too. And of course, more importantly, your terrestrial electrical systems can also be fried by induced currents in the actual power systems. So it's important that we understand how these coronal mass ejections affect the planet, also how the mechanisms behind them, and also, more importantly, how do we detect them in the near real time so that we can give early warning to essentially systems that are going to be affected by it. So we need a tool to do this, and the tool that we use is the International LOFAR Telescope. So ILOFAR is basically the Irish Low Frequency Array. So the acronym LOFAR is Low Frequency Array, and the I, of course, Ireland. And you can see from the map here that it's spread across a number of European countries. So it's a pan-European project. Excuse me. The picture here shows you the ILOFAR station that's actually in Birr, and you can visit. If you go to Birr Castle Domain, you can wander around and you can actually look at the LOFAR array. It's not very spectacular because it's basically a flat piece of ground with some antennae sticking out of it. That's to the right of that kind of spectacle-shaped ground, and then the one that's left looks like a load of covered pallets. Effectively, the high frequency antenna. It's not very spectacular. The optical telescope in Birr is far more spectacular looking, but nevertheless, this is an integral part of the International LOFAR Telescope. It generates a significant amount of data. So there are 50 stations scattered around Europe, from Birr in the west to Rosen in Bulgaria in the east, from Onsalada and Irben in the Baltic down to Medicina in Italy in the south. Each station produced about 3 gigabits per second of data. And if we have 50 stations, it's 150 gigabits, not quite, but close to 20 gigabytes. So you can work out then, over a minute, you're talking 1.2 terabytes. Over a day and a year, you're looking at exabytes going to of data. So it's a lot of information. And recently, we've upgraded the system, or in the process of being upgraded, now it's 10 gigabits per second. So far more power with the system, also be able to detect events which are further out into the universe, as well as locally as well in our own solar system. At the bottom of the map, you can see the 8 consortium members making up the ILOFAR consortium. Trinity and Dias, who we work very closely with, basically run the system. Trinity actually have leased the land, and Peter Gallagher in Dias, who was in Trinity, was the founder, as it were, of the ILOFAR system. And then we're lucky then to have a number of researchers working with Dias in collaboration with Dias and Trinity on essentially using methods to detect and improve the classification of the solar radio bursts. So as I said, we have to detect something. How do we find this object? So let's start off with something that we're all familiar with, which is essentially the face detection. So in case we could use something like this, which is a cascade classifier, which basically scans around the image with certain types of mathematical functions, but finds a candidate object. It stays in that region, applies more functions to it, and bingo, you detect the face. It is fast. It's very memory efficient, so it can be used on edge devices. Slow to train, though, that's the problem. And it does have large false positive effects. So you can see it's detect the face here of the footballer, but again, it's saying the hoarding behind is also a face. It's not right. You can use histogram gradients with support vector machines, and what that does, it takes effectively like a contour of the image in terms of its intensity and its color information, and from that, it can actually determine whether or not something inside that image actually corresponds to a face. So again, you get elliptical regions around eyes and mouths, etc. So you can say, okay, I can see based upon the contours you see in the map, yeah, I can see how this could work for an actual image. It's fast, it's accurate, simple to understand, but again, training it can be an absolute pain. Exemplar methods make more sense in the sense they're more categorical methods. They're basically what you do is you produce a series of models of the different types of objects you want to do, like different classifications of that model, or categories, and then your system detects and sees whether or not one of these examples, the exemplar, actually corresponds roughly or very close to what you're looking for. But again, it's a lot of work behind the scenes to get the system up to that level. And then we come to the, I suppose, the bread and butter one, and nowadays, because we have significant computing power available to us, we can use these far more frequently, probably too often in many respects. There are probably better methods that can be used that are more computationally efficient, but people tend to jump in and use neural networks as a kind of a starting off point. What this does is basically this convolutional neural network. It takes information in, it performs some mathematical filtering on it, and it passes into a neural network. And if it works, then it can actually pick out features. So in this case, this yellow kind of 3x3 block here is a filter that's being applied to parts of the image which have been green. It's producing a smaller image which contains information that's pertinent from that image, and then it can then downsample that and provide information to a feature vector, which goes into the neural network. So you can see in the case of the bottom, we have two features. We have a filter which has a elliptic going backwards and a filter elliptic going forwards, and they produce two feature maps, and you can apply many different types of ones. You can have horizontal, vertical, cross-shaped ones, X-shaped ones, etc. And the idea is that you try and find out information from these filters, and then you put that into your network, and hopefully you find something that's useful. You can have regional CNNs, which basically, instead of taking the whole image, they take part of the image and then see if that actually produces something that's of a good candidate for what you're looking for. And then there's mass score CNN, which uses image segmentation, which actually outlines the object it thinks is an example of what you're looking for, and says, okay, this looks like a person, this looks like a car, etc. Now, as I said, these are all computationally very intensive. And that creates a problem, because most of these don't have to be done on servers, they can't be done on the edge. We use a thing called YOLO, which is you only look once, and we've modified it to suit our needs. So object detection, that's where it is roughly now at the moment in terms of finding objects that you'd be familiar with. Everyday objects, cars, people, phones, bottles, that type of stuff. Excuse me. Now, to detect SRBs, solar radio bursts, is slightly different, because these things are not simple objects. These are abstract objects. What we do is we have to take the signal coming from the LOFAR telescope and turn it into an image. And so we have in the horizontal time, and in the vertical, we have frequency. And we use simulated images. So one of the postdocs on the Peter Gallagher and Dias, Owen Carley, he came up with a means of actually parametrically simulating these kind of solar radio bursts. And you can see they're not bad. They kind of have the general shape of a solar radio burst, which is the one on the right, but they're not perfect. But they are simulations. You can use those simulations with real observations, and you can train them. And again, 80,000 examples of what you typically use for CNN. You have 15,000 then for a test set, so it's a lot of data. So unfortunately, and I have a few PhD students who will attest to this, it does require a lot of computing power and a lot of patience and perseverance. God love them, they have to spend months annotating images. But there are shortcuts now we can use nowadays. I didn't tell them about at the start because I think it's fun for them to actually do the manual scaling. But hopefully they won't see this video, because otherwise they'll come back and haunt me. Now, in terms of accuracy, we get about 82% accuracy, but slightly more than that in some cases. But the problem with this method is using this in simulated data is that in the case of the left-hand box that you see here in green, the SRB is only extending halfway down through the frequency range. There's also this thing that looks like Morse code to the left of that first box. That's actually radio frequency interference. That, unfortunately, radio telescopes are prone to interference of that type, and we have ways of mitigating that. And if we've time at the end, or if someone's interested, I can talk to them in the Q&A session. The problem here is that all these boxes are roughly the same height, and they're all roughly the same width. That's no good if the SRB is of different sizes. So we needed something else to actually detect these far more efficiently. And so we went back to our computer vision, and we looked at some of the work we're doing with EssilorLuxottica, the world's largest manufacturer of eyeglasses. We've worked with them for the last 5 years on digital imaging and virtual face generation. And we decided to use a thing called GAN. And GAN is Generative Adversarial Network. And effectively, don't worry about this complicated diagram. These are basically two convolutional neural networks. The important thing here is imagine an art forger. So you've got a guy who's forging pictures. And he passed them to an expert, and the expert looks at them and he said, "Oh, no, they're rubbish. No, forget about them." So the forger learns from the feedback they get from the expert as to what change they have to make to these primitive, bad, crude forgeries at the beginning, and they make them better and better and better. And if, again, there are issues with these as well, because sometimes they can come unstable, but assuming everything goes according to plan, you can actually create images that are synthetic in the sense that they look actually real. They're realistic. And they're not simulation where you know it's not real. These two, like I said, the generation and scrim, they compete against each other. So they're fighting, but that's it. Now, if I showed you these 6 images here, you can see 6 images of people. And if I said to you, okay, you numbered them top to the bottom, left to right, 1, 2, 3, 4, 5, 6. And I said, okay, how many of these are actually synthetic? How many of these are false? They're all fake. Every one of these 6 images is fake. So GAN can actually produce photorealistic faces that actually don't exist. These people don't exist. And that's what's frightening in some respects. But then again, it's useful for us in terms of the SRBs. So it's used for face generation and creating avatars. And also it can be used as well for training systems that can actually essentially characterize faces. So we have used that with, as I said, with Luxottica. We're going to apply now here to SRBs. So I'm going to show you the final result instead of going through all the complicated details because it gets messy. So here we have essentially the final result. On the left, we have parametric modeling. On the top, we have a type 3 SRB, which are quite common and they're a simple structure. On the bottom, we have a type 2, and that's more associated with the coronal mass ejections like an explosion. In the middle, we have real observations that come from LOFAR. And top is, of course, your type 3, and you can see it's similar to what we saw previously when I introduced you to the simulated type 3. On the bottom, type 2, and you can see that, well, it looks, the one on the parametric model looks like it's been shrunk and blurred compared to the real observation. On the right, we have the synthetic ones that we produced using observations that were actually existing at the time from the LOFAR archive. And you can see that the type 3 are far more realistic than the parametric one, which is on the left. And more importantly, the type 2, which are very, very difficult to model parametrically, look far more realistic than the parametric one on the extreme left. Also, the GAN one also introduces and embeds into type 3s that can actually occur as well, and the herringbone effect that occur with the shocking or the shock propagation that goes through when you have a coronal mass ejection. So the synthetic data, again, this all came from looking at faces and face generation. We applied that then from an industrial project into a more pure kind of astrophysics project, and it's been very, very successful. And this is the type of data we actually typically look at. We don't look at those nice clean images. We look at something like this, which is the top. You can see from basically up to 20, we have all this radio frequency interference. And then from 30 to about 90 is where we actually typically see that the SRBs we're interested in. There's a few lines across here. There's one around 37, there's one around 78. They're actually radio frequency interference that's persistent. But every so often.
Mark, how are you doing for time there?
This is the last slide.
Oh, very good. Okay.
Last slide. So
carry
this
on.
I'm finished. So literally, sorry, in the around 1256, you can see this is kind of, again, this looks like Morse code in the sense, little band. And that is radio frequency interference. That's burst mode. That's actually horrible. We don't want that because you can actually confuse that with an SRB if you're not careful. So we've actually introduced methods to mitigate that, but that's for another discussion. We don't have the time here to discuss it. But you can see in the bottom, there's our detections of the SRBs, and the boxes you can see are different sizes, different heights, different locations, and they're actually allowing us to pick up where the SRBs are, and more importantly, what shape they are and the size they are. And that allows us then to characterize and classify them and the severity and what they're doing. So again, in conclusion, what we're doing is we're taking computer vision and we're applying it essentially to astronomy. And it's a way where you can take lots of different technologies and apply them to essentially space and problems, effectively. That's it. So I'll stop there.
Okay, thanks very much, Mark. I was muted there. That's fascinating. I think like any good talk, it raised more questions than it answered. So hopefully, we'll have some questions for you at the end.
Hopefully not questions like what the hell is you talking about?
What was that dot on the slide there? And
What's that?
slide
Exactly.
two, yeah.
Perfect. That's
So
great.
listen, thanks a million, Mark, and
No problem.
I'll hand over to Alan, who's going to talk to us about the KPMG survey. I participated in that survey. I was interviewed by some of the guys from KPMG, so I'm interested in hearing about the results and how it's going to fill some gaps in that space strategy that Niamh talked about. So over to you, Alan.
Yeah, thanks, John, and good afternoon, all. Let me just bring up my PowerPoint. There we go. So hopefully you can see that now.
Yeah, that's perfect.
So yeah, perfect. So welcome. So I'm going to do a brief chat about Space 4.0 itself. And Niamh and Mark have already touched on some of the elements that's going on in space. So I'll briefly go through it, and I will, as John say, I will give some feedback on some of the KPMG survey that we recently did in 2023. So just a very brief intro, just for those who try to gauge the audience here. I'm not sure who are familiar with the whole Space 4.0, but Space 4.0 is effectively the privatization, the modernization, but privatization in particular of the whole space domain. Up until Space 4.0, space was very much a public entity, the domination. Now it's after really changing. So in approximately from 2010 thereabouts onwards, it really has changed, and there's a lot more private industry. There are some private-public partnerships going on, and Niamh mentioned it with the likes of SpaceX and whatnot. So there is private-public partnerships actually going on, but a lot of Space 4.0 as an industry is very much private. It very much leads to and is driven by the whole societal impact. So again, the Earth observation data being one of them, but there are many other in terms of AI development, edge computational development, as Mark was just saying, understanding and getting real time or pseudo real time understanding of solar phenomenon and so on. However, the one distinguishing element between the public and what the privatization is doing is definitely the commercialization side of things. That is very much driven by the private sector, and that is one of the key areas of the whole Space 4.0. It's primarily a disruptive, or certainly reasonably well dominated by disruptive technology and processes. So you do have technologies being developed, but you also have technologies which are absolutely in situ across the globe, but can be transitioned into space. So you have the two elements of development and transitioning to become a disruptive element and a disruptive technology. Space 4.0 as an entity is most definitely driven by the digitization, and this is where it crosses the border into the industry 4.0. That whole digitization element of it, where components and processes are smaller and lighter, cheaper, faster. And that then leads to, through using the likes of commercial off-the-shelf technology and platforms, which again is very, very strongly prevalent within the private industry. So again, another minor differentiator between the public and private, because with the public space entities, they're generally bespoke systems that can have quite a long development time frame. and quite often put into orbits that are not necessarily that require these long time frame because they need space, radiation hardening, and so on. Whereas the new Space 4.0, which is a lot of the low Earth orbit elements of the industry outside of it, is very much off the shelf and has a much shorter life cycle. In terms of the industry, I won't spend long on this now because some of you might know a fair bit of this already. So it is set to become a $1 trillion industry. In the last couple of years, it's been in and around the 400 billion, just over 400 billion dollar industry, and it's set to become a $1 trillion industry by 2040. You can see here Morgan Stanley and Citigroup, both at various points, doing surveys and reports indicating, you know, a $1 trillion industry is well on the way by approximately 2040. It's driven by digitization, large cost reductions in the launch, which comes back to the whole cheaper and faster component systems. And then, as I say, using commercial off-the-shelf approaches. The low Earth orbit in particular, elements of it are being used as a service, so satellite as a service opportunities. Again, this was briefly touched on, but using the satellites to Earth observation data is one example, but there are many others. But it is one area which is very prevalent, very, I suppose, high profile, certainly at the minute, using Earth observation to gain an understanding of, you know, the Earth climate impacts, climate change, high resolution imagery, and so on and so forth. One of the interesting elements that came out of the KPMG survey was economic analysis did estimate that an increased engagement across maybe some of the weaker sectors, which I will touch on later, could have a gain in the range, a lower range of 116 up to maybe 150. There are some caveats to that, of course, but that's approximately what it's saying. So you can see that there is absolutely some economic incentivization and commercial incentivization to get involved in the space sector for anyone who wants to. A brief overview of the landscape. Again, this was touched on. So here, up until Space 4.0 came along, it was predominantly governed by Enterprise Ireland and the European Space Agency contracts, that kind of area. This was also born out of academic research. So you would have had a number of players who would have started out maybe in academia doing academic research, and then either had a spin-off industry or a spin-off company, who then ended up becoming, through Enterprise Ireland, associated with ESA contracts and so on. So that would have been a very stereotypical kind of path in the space sector. The ISU coming to Ireland in 2017 was actually quite important for us. We hosted it here in Cork, in MTU, and it was quite a big thing for us and in general for Ireland, certainly in the space area. It did lead to the space strategy, which has already been mentioned, the 5 pillars. One of the takeaways, one can take from what's happening in the landscape at the minute. So traditionally, a lot of countries would have had basically an anchor. So a large aerospace company, the likes of a Boeing or an Airbus or so on and so forth, they would have had them as an anchor block for their space industry to be successful. However, again, through the survey, we have realized that you don't actually need to have that anchor. You can actually be a flourishing and strong space economy without actually having to have that anchor. There's plenty of opportunity out there if you know where to go and look for it. So very briefly, just in case anyone is unaware, there are 3 main kind of sectors to the space 4.0. So there's the upstream, the midstream, and the downstream. The upstream, briefly, the satellite technology, and the ground facilities for satellite control. The midstream, the ground stations and whatnot for communications back and forth. You'll actually see on John's avatar the ground station over here in Middleton, the NSC, which is one of actually the strongest, westernmost teleport in Europe. And then you have the downstream. The downstream is by far the one that's gaining the most traction because of all the data that's been generated by Earth observation and others. The application space, in particular for commercialization of it, is a very strong development at this point. However, it should be noted, and this again came out of the survey, that awareness of opportunities is actually quite low within general commercial industry. So, and yet at the same time, a large portion of general industry across Ireland do realize that at some point the space industry could be important to their sector. So it is important to actually start to consider getting involved if you're not already involved, because at some point you are likely to cross paths with it. And from an Irish point of view, a series of advancements in policy could, we have found could develop a solid platform for economic activity for which, Europe and the world, but Ireland in particular, would stand to gain. And as a result, or on top of, the likes of the companies and industries across Ireland, it effectively leads to more opportunities for all. So the industry sectors well represented, and a lot of these would have contracts with the likes of Enterprise Ireland or European Space Agency through EI, would be in terms of electronics, software, in particular software on board satellite systems, but it's some downstream in manufacturing, in telecoms, and in R&D. Some underrepresented entities in space, certainly in an Irish context, would be the IT services, life sciences, construction, energy, and there's a few more in there, like agri, for example. So agri is a unique one because it does have representation and pretty good, but there is a lot of room for expansion on it. But these sectors you're looking at here, which are underrepresented, are entities and our sectors that are quite strong in Ireland. So we do a lot of life sciences and IT services and energy and whatnot in Ireland. So they are sectors that we feel can play a stronger role in space. It's just a matter of engaging with the space sector. Emerging sectors overall, and I'm conscious of time, John. So there are a couple of sectors in Earth observation, commercialization, cybersecurity. I may not get onto today. If you want to ask about it, please do. Because that is becoming a big player, and Ireland is actually quite strong in cybersecurity. AI and edge computing has already been touched on by Mark and Niamh. But interestingly, AI, for example, we know that there is also a sector working on how you develop power optimization using AI for satellite systems in particular, because that will allow you to reduce the weight of your payloads that you're sending up there, and which reduce the cost. Weight to cost is always a big thing for sending satellite systems up there. And then there's data analysis and quantum computing. Data analysis in particular for on-system, on-chip, kind of linked to edge computing in some way. But and Niamh mentioned Ubotica. So these would be some of the systems that the likes of Ubotica will be looking at, where they're analyzing images on the actual satellite system themselves before sending it down, or making a call whether it's a valid image to send down or not. So Earth observation, data-driven, highly data-driven as an entity. A lot of data, in particular image analysis data going on, but there's a lot of multi-frequency analysis going on as well. Throughout the Sentinel satellite systems are quite an extensive suite of satellites with a lot of data. So it's very much a case of, at the minute, there's not enough people actually analyzing the data. There's too much data coming down. So trying to get that downstream element up and running and getting involved in actually analyzing the data is quite important. In in terms of Galileo. So Copernicus, which is the Earth observation and Sentinel kind of data, and Galileo then being the GPS. It's down to 20 centimeter resolution at the minute. There's obviously new GPS systems coming online in the future. They will be even more resolute. The reason I bring these in is, first of all, when it comes to, again, going back to AI and cybersecurity and whatnot, there are downstream on Earth elements such as automated vehicles and whatnot. So there's a whole suite of technologies which will come online and are coming down the track. We all know of the testing that automated vehicles have been going through over the last decade or so. So they're going to require GPS, obviously down to higher resolution than 1 centimeter or 20 centimeters it is currently. But they're also going to need a lot of AI to be able to operate autonomously in any way, shape, or form. We mentioned the space strategy just so that you're aware for various sectors of engineering. There are specific calls to get data hubs up and running, and Ireland has identified a data hub as something we should be interested in doing. So it's something to keep an eye on, because data centers and data hubs are absolutely going to play a crucial role, and we all know there's a lot that goes into building a data center and how these operate and run efficiently. Cybersecurity is going to become very important in terms of my time is nearly up.
No, carry on.
I'll leave the cybersecurity. If you have a question about cybersecurity, please drop it in the Q&A. I'm happy to talk about it, because it actually is an up and coming element which is going to be important. So 4 very quick things, which again, part of this came out of the survey. So if you want to get involved, there are kind of a number of ways, but these are 4 just rough example ways of getting involved. So you have your Enterprise Ireland and your European Space Agency approach, feasibility study, and so on, which is a lower cost entry into it. But then there's the larger project side of it as well, which Niamh touched on. There's the academia, there's research, there's the clusters and the gateways and the centres all dotted throughout Ireland. They're going to be all around your location, no matter where you are in Ireland. There's going to be a cluster or a research centre somewhere near you. There could well be ways of getting in there. If there isn't, just make contact with them. EU programs, I will touch on in a second. There are venture capital for those in engineering who would want to, really go the venture capital privatization side of it. There are VCs. These are just 3 I named. There's more out there. But you go to them, you pitch your idea, or you look at what they're doing and see if you can get involved in an idea. There's a couple of ways of doing it. Last slide. So these are just 3 or 4 EU funding, and I can actually just leave this slide up there and just finish it on here if you want, John. So you can see USPA, which Niamh mentioned. You can actually see under USPA the cohort and the areas in terms of engineering that the European Union are actively looking for people to get involved in space. So they want people from road, automotive, infrastructure, forestry, emergency management, etc. They want everyone from across these sectors to get involved in space, and there's funding calls out there in all of these areas for people to get involved. So I would just urge, certainly go have a look at USPA and the Horizon Europe, the Health and Digital Executive as well. 45 new projects for 218 million. So there is a lot out there. For those who are up and coming, there's the accelerator. Look at the accelerators and look at the hackathons for the likes of Copernicus, and the accelerator program for the EU Innovation Council as well, which has a new program manager who actually is out of the ISU, but for space systems and technologies. So I'll leave it at that. Thanks, John.
Thanks a million, Alan. That's fascinating. I know when you touch on subjects like cybersecurity, artificial intelligence, edge computing, there's a huge crossover with what we're doing in manufacturing support and automation. So there's definitely skills in Ireland that can be applied to those topics. There's definitely interest there, so it's going to be interesting. So I have a couple of questions, and we're tight on time, but we'll stick in a few questions. Brian asks, do you reckon the Galileo system will replace GLONASS? So I think GLONASS is the Russian GPS. and GPS is the American GPS, and Galileo is the European one. Am I right? Does anyone touch that? Do they all talk together? Do they all work together, or do they compete? Does anyone want to talk about that?
So the question is, do I think it will replace it?
I think, yeah, I'm not sure if Galileo, if the questioner means will it replace it, but I'd be interested in knowing myself. They're all operating simultaneously, so are they competing, or are they can they be used as a backup to each other? If something happened, if there was a failure on the GPS system, could we all switch over to Galileo?
I'm not sure. I'm not sure the space policy of that, but I think the point is that Galileo is through the European arm, so we have access to those satellites more easily. So if you've got any business ideas or anything, Galileo is the one. GLONASS would be something that would be outside our remit. And I'm sure there probably are collaborations, but I wouldn't know. But that would be more of a space policy question, which is above my pay grade, John.
Fair enough. Fair enough.
And there might be, just on that, John, there might be something as well. I remember reading an article about that with post-Brexit, the UK might not actually have access to.
True.
They might have access to the public aspect of Galileo, but not to the more accurate version that's used by the military. So
you have to sign up to that one.
Yeah.
Okay. Alexander asks us, is there any chance that Ireland will have a space agency of its own? I know that, again, maybe it was linked to Brexit, but there is now a UK space agency for the first time, and there hadn't been for a while. Is there a chance we'd have an Irish space agency? Would it help the economic, social, political?
I think the space policy, I'll let Al, you can jump in as well, but I think the space policy is a really important first step towards that, and I think Ireland is a much smaller country than the United Kingdom. I mean, the United Kingdom it's got kind of it's got a para astronaut and an English astronaut. It's already had Tim Peake and then Helen Sharman before. So they're able to invest an awful lot more than Ireland does at the moment. But I mean, yes, it would be great. But I think the space policy is the first step towards that. Al, what would you add to that?
Yeah, I would agree, Niamh. Certainly for an agency, even though some countries not too dissimilar to us do have agencies, but I think needs must. That there's always the question. We're on the doorstep and we're part of the EU. Do we need an agency? Certainly, the Irish Space Association, for example, will handle a lot of business elements of it, and we're looking at clusterization, which is prevalent across a lot of Europe. So having clusters, regional clusters, for example, as models to enable businesses to get involved in the space industry globally. So it will boil down to policy. Is there a need for an agency at this point in time? Probably not. Will it come? Who knows?
Okay.
One last thing. I'll just jump in as the communicator. I think in terms of for marketing and outreach and people's awareness about the Irish space sector, I think an agency would be a really positive thing. But we do have, there is Education Resource Office arm of the European Space Agency, and then there are things happening like Blackrock Castle Observatory rollout. Space Week annually, which happens every year. But I think from a PR point of view, it would be nice to have a face of the Irish Space Agency. But I think Al's points are bang on.
Okay, so just before we close, and I'm being selfish, I'm going to jump in with my own question from Mark. The low-FAR array and the European-wide array, does it have any applications with SETI, with Search for Extraterrestrial Intelligence?
It can, and this is the thing. I was talking with Peter there only a while back, and he was saying if someone could use something like LOFAR to actually detect a signal out there, because you've all seen the film Contact, where she was using the array in the Mojave Desert, I think is it, but she's using that array again to detect a radio signal. So yeah, if it could be done. The problem is that, as I said, you're dealing with over a year, you're dealing with exabytes of information. So the thing is, you have to look now for a specific type of, and that's the resource. So the work we're doing has come from high definition real time video classification, and we've applied that. So gigabit per second kind of video. Our data analysis, and we've applied that then to the low-FAR signal, so we can do near real-time analysis at the moment, and with a bit extra work we could get up to real time. So that's the point. Is But again, the problem is that they've now increased low FAR to low FAR 2.0, which is 10 gigabits, 3 times more. So we're constantly trying to catch up with the technology. They're increasing the speeds, and we're trying to keep track with them. So it's yeah, I feel like Sisyphus at times. I get the thing up one side of the hill and the roads on the other side. I got to run it back up again. So yeah, it's.
So
But, yeah.
I think we've hit our time limit.
So
and
John,
thank everybody.
John, can I just finish on one comment, and it's relevant to what Mark and Niamh were saying, is there's a massive amount of data being generated, no matter what sector you're in, that from space, and there's not enough people, companies, and industry actually looking at the data and trying to figure out what to do and analyze the data. So there are massive holes and opportunities for anyone who wants to get involved, no matter what industry you're in.
And the same data can be used by multiple people to look for different things. So Mark can be looking for SRBs, and someone can take the same data and use it for looking at for SETI and so on. So
there's the foundation of the apps. All apps use a lot of satellite data. Like if you have a business idea at all, like go for it. And
if you're generating new kind of algorithms or new techniques, you can use these data repositories to train systems and see how effective they're going to be, and then actually then apply it then to your own data. So it can be used as a kind of as a reference data set or a repository in that case. Yeah. So it's
okay. So listen, again, we had to leave some questions unanswered. Maybe I see people typing in the chat. So if you want to just type some answers in the chat, or we'll talk to Engineers Ireland and we'll see, we might have to reconvene and have another discussion, because I have loads of questions that I didn't even get to ask. So listen, thanks very much to Alan, Mark, and Niamh, and thanks to all the attendees. And again, it'll be recorded. It'll be on the YouTube channel. Just keep an eye on your Engineers Ireland website. Thanks, guys.
Thanks, guys. Take care.
Bye-bye.
Thanks, everyone. Bye-bye.